So hi everyone, welcome back to my YouTube channel. In this video, we'll learn everything relating to plots in MATLAB. So let's get started. First of all, very basic, I want to create a 2D plot. So for 2D plots, I'll define the x-axis. X-axis is a length state 0 to 2 pi. So if none of the values are given, then by default, length space will take 100 values. Then y is a function of x, y is sin x. I want to plot sin x from 0 to 2 pi. So now the command uses plot x and y. But let's say I want to change the limits. I don't want from 0 to 2 pi. Although the calculation is done from 0 to 2 pi, I want to increase the area. So instead of 0 to 7, 7.5, I'll have the x limit set to 0 to 8. So now I'll have some extended area in the plot. Then I can also have the y limit similarly from minus 1.2 to 2. Now these are used for labeling. X label is labeled as x and the y label is labeled as sin x. And this y label, you will be seeing the interpreter is different. By default, the interpreter is none. So it only reads text. But if you want to have some mathematical formula, then using interpreter latex is beneficial. So then we're having this \sin x. Beneath this, between these dollar signs. So this will be represented as a latex typeset. Now the title of the graph is this. This is the result that you'll see. These are the x level going from 0 to 8, y level going from minus 1.2 to 2. This is the title and this is the length. This is the plot. Now let's say I don't want single plot. I want two different plots. So how can I do it? So now, since we have understood all these things, I won't discuss it again. Now I'll do simple plotting. Again, x is length space 0 to 2 pi, y is sin x, plot x. The only difference is now I have hold on command. What hold on does, it holds on that finger and the next plot is added as a next layer to the same plot. Now again we define y2, which is cosine x. Now you'll see this thing as well. This is the type of plot that you want to use. And this new thing is legend. Legend is differentiating between the two plots. Now once both the plots are plotted, you'll have this hold off command. So it lets go of the data. It doesn't store it. So here you will see two different plots. This is the sine and this is the cosine. Now sine is a regular straight line plot, while cosine is the dotted plot. So this dot actually makes a dotted plot. We'll see this in detail. These line plots or dotted plots, we don't want to connect the different data points. I just want the data points plotted. So this is what we call a marker. So now using this marker, only the data points are represented and these are not, they are not joined in between. Now we can have a huge combination of all these things. Let's say again x and y are defined similarly, but now I want to have different options. These are the different options that we can use. First, what is the color of the plot? Color equals R. R stands for red. Then what is the line style? Line style is straight line with no gaps in between. Then what is the line width? What is the width of the line? That is 2 units. Now, at the data points, what is the marker? This x represents the data points and straight line is used for joining these two markers. So all the data points are represented by x. Marker size is 15. Marker edge color is blue. What is the edge color? And what is the face color? That is fill color. Sometimes it can happen you only want an outline. Like in the above plot, you only had a circle with an outline. So this marker face color was not needed. But here I want a filled cross. So the plot now looks like this. So whenever you want to use any of the options, just select plot, then select D, then you get a lot of options here. We'll have all the examples here. You can use any of these. It is one of the examples that I've used here. Now coming back, instead of a 2D plot, I want to plot a 3D plot. So now earlier we were using plot command, now when we're using plot3 command. Again we have this parameter t, then two functions of the parameter, sin t and cosine t. Now this is first function, second function and the parameter. So this is a helix. Again we can use similar commands from there. We can change the line style, line width. We can hold on the figure. We can draw two different figures. Also, instead of hold on command, we can also use like this. We have the first three. This will make the first plot. And the next three will make the second plot. Whenever we are using plot 3. If we are using just plot, then it will take pairs. First two, then the next two, then the next two. So these are the two different ways where you can superimpose two plots. So here you can see two different plots. One the blue one and the other one is red. Now again using the markers, not connecting the markers. Now connecting the markers. So these are the plotting commands. Then dash O. Dash O stands for, dash is the line joining the O markers. So all these markers are O and then you connect it with a line. So this is what it means. Color is blue, marker size 10. Now these three dots represent that you can write the command in the next line. This is just a continuation of that. So either you keep everything in one line or you move it to next line by inserting these three dots. Then these are considered in continuation. This is one command. This complete is one command. So now the marker face color is, this is a code that you can use, or else the color definition. If some variation is other than some preset values like red, green, blue, these are very popular colors. So we have smaller inputs for them. R for red, P for blue, G for green, K for black. But if you need a combination, if you need a shaded color, then you can use these type of commands. These codes, each different code has a different shade of color. Now, simple plots are done. Now, if you want to create surfaces, now you have to note that for surfaces, you'll have to be sure that both the axes are defined. So what it will actually do, so I have an x-axis defined and a y-axis defined, and at each intersection of the two, it will take a multiply. It's a tensorial product. So it creates a matrix of xy coordinates, and then at each xy coordinate, it will calculate the z. So each xy coordinate will correspond to a different height. This is what we mean by a 3D surface. Then we use the surf command to plot the surface. X and y need not be same, but they must form a matrix that each combination of x and y must have a corresponding z for this command to work. This one thing I have left. So instead of having one plot at a time, we can also have multiple plots. We don't want to superimpose the plots, but we can have subfigures. So we can use this tile layout command, where the first entry represents the number of rows and the second entry represents the number of columns. So we can have 4 figures. This is the title of the layout. Now in next tile, we'll move from each subplot. First is this plot. We go to next tile. Next tile is 1, 2. This is 1, 1, 1, 2, 2, 1 and 2, 2. And then we plot the command. So here you can see we have 4 subplots. This is different than superimposing of 2 plots. So these are the different functions that you can use by plotting. And also you can play with all these things. Apart from creating all these simple shapes, simple plots and simple surfaces, you can have various combinations of all these things. And whenever you have any confusion with what the inputs that are required, then you will just select this, put Ctrl+D and then check. Else, what you can do, you can just go to Home, Help. Again, it will open the Help Center and then put here let's say I want to know plot 3. So I'll go to plot 3. I'll see how many inputs it can take, what are the various combinations, and then different examples. So this is the very basic video required on MATLAB plotting. I hope you learned a lot about MATLAB plotting today. And in the next video, I'll be teaching about symbolic math toolbox. This is a very powerful toolbox presented by MATLAB. Thank you.